day and welcome. Now solutions for class test 2, just on exponents, 25 marks. I hope this helps you in studying and preparing. So as I explained in the previous one, there's all the problems and how we put it together. Let's look at the solutions. Right, so 1.1, simplify. In brackets I have base A, exponent m plus 1, in brackets outside m minus 1. So this is testing law 3 of exponents, meaning must multiply all the exponents inside with exponents outside. So there, because this reads m plus 1 and that m minus 1, we are testing difference of two squares, meaning first term times first term, m times m, positive times negative 1. So m times m gives me m squared. That simply becomes negative 1. So 1 mark for m squared and 1 mark for minus 1. Can multiply out. M times m would give you m squared. M times negative 1, negative m. 1 times m, positive m minus m cancels. And then 1 times negative 1 gives you negative 1. 1.2, as I said, in general, we will test multiplication and division of exponents. Right? And generally, we start off grade 12 or grade 11 work with whether you can create prime bases, right? So you see 10 is not a prime number, 50 is not a prime number, 100 is not a prime number. So the prime base, 10 can be expressed as 2 times 5, where 2 and 5 are both prime numbers. 50, 2 times 5 squared is 25 times 2 gives me 50, but now 2 and 5 are both prime bases. 4 is not a prime number, can be expressed as 2 to the power 2. 100 is 4 times 25, or 2 squared times 5 squared, and 5 is already a prime number, so it stays the same. Right, so 1 mark for the top row, another mark for the bottom row, correctly changing to prime bases. Right, now we're testing law 4 and law 3 of exponents, meaning all exponents inside the bracket must be multiplied with exponents outside the bracket. So 1 times n gives me n. Therefore, base 5, 1 times n gives me n. So 5 to the power n. Here again, 2 to the power 1 times n gives me n. 1 times positive 1 gives me positive 1. 5 to the power 2, 2 times n gives me 2n. 2 times 1 gives me positive 2. There, 2 times negative 2 would give me negative 4. There, base 2, power 2, 2 times n gives me 2n. 5 base 2, 2 times n gives me 2n, and that simply stays 5n. So 1 mark for correctly multiplying out my exponents. Right, now we're going to apply law 1 and law 2 of exponents. So if I take my base 2, everything on top is written as it appears. So there, n plus 1 minus 4. If I come below the division line, I'm subtracting. Remember, second law of exponents, we subtract exponents. So therefore, that simply becomes negative 2n. Go to base 5. On top, I have n plus 2n plus 2. If I come below the division line and we change the signs, that becomes minus 2n minus n. So n plus n, 2n minus 2n cancel. 1 minus 4 gives me negative 3. The n plus 2n gives me 3n, minus 2n gives me 1n, minus n cancel. I'm left with 5 to the power 2. Remember, we're not allowed to have a negative exponent as a final answer. So 5 squared stays on top, but 2 to the negative 3 goes to the bottom and become 2 to the power 3. 5 squared is 25. 2 to the power 3 is 8. So 1 mark for my final answer. There, 1 mark for law 1 and 2. So hope you understand. You're going to be doing the same thing. The values are just going to change, and you have to find prime bases. If you struggle with prime bases, make sure you get you a Casio FX82. And on that calculator, if you press 50 equals shift, in fact, it will give you that it is 2 times 5 squared. Alright, let's look at the next problem. Alright, now in 1.3, again I have exponents, but they're separated by a minus sign. So generally there we are testing common factor. But given 2 to the power n plus 5 minus 3 times 2 to the power n minus 2 over 5 times 2 to the power n plus 3. Now the first step here by splitting is to make sure you don't make an error. You don't get a mark for it, so you don't need to do it. But if you're error prone, just get in the habit of doing it. So 2n plus 5 can be expressed as 2 to the power n times 2 to the power 5 minus 3, there 2 to the power n times 2 to the negative 2. The bottom I have 5 times 2 to the power n times 2 to the power 3. So now you should see there 2 to the power n, 2 to the power n, 2 to the power n. Take it out as a common factor. So if I take out 2 to the power n, I'm left with 2 to the power 5 minus 3 times 2 to the negative 2. The bottom I've just rearranged and wrote 2 to the power n there, 5 times 2 to the power 3. My exponent with the variable will always cancel. So 2 to the power n cancels with 2 to the power n. Most of my exam questions, and now I have to simplify what's left. So 2 to the power 5 gives me 32. There minus 3, 2 to the negative 2. To make it positive, I'm going to take it to the bottom, so it becomes 2 to the power 2. The bottom I have 5 times 2 to the power 3, which is 8. So now I have 32 minus 3 over, I assume you know 2 squared is 4. Right, and 5 times 8 would give me 40. 32 minus 3 over 4 would give you 125 over 4, or 31 and a quarter, whichever way you want to write it. Change division to multiplication. 40 over 1 become 1 over 40. Right, 125 times 1 is 125. 4 times 40 is 160. 125 over 160 would simplify to 25 over 32. So there, 1 mark for common factor and another mark for leaving the correct values in a bracket. Another mark here for simplification of the top line there. And another mark for final answer. So that's my 4 marks. So as I say, general questions for exponents, there must be 1 multiplication and division. There must be 1 addition and subtraction. Let's look at the next one. Right, so now here we're just testing your definitions. Do you understand how to work with negative exponents? So we have 1 divided by x to the negative 1 plus y to the negative 1. To make it positive, it can become 1 over x plus 1 over y. Now to add 2 fractions, the denominators must be the same, meaning I either have y, y, or I have x, x. Right? In this case, I have 2 different values, so instead of complicating my life, I just multiply them. So I'm going to say x times y, right? And then all I'm going to do is that y I'm going to cross multiply. So you see y goes on top and at the bottom. This side, I'll take x to the top and to the bottom. So that becomes x over xy. That becomes y over xy. Now, because the denominators are the same, I can add the numerators, so that becomes y plus x over xy. Right, change division to multiplication, so that will become 1 times xy over yx. Remember, I invert the fraction, meaning I flip it around. Right, and 1 times anything stays the same, so my final answer, xy over y plus x. So 1 mark for correctly changing that to positive exponents. Another mark for making my denominators the same and correctly multiplying across. Another mark for adding and putting under 1 denominator. Another mark for inverting my fraction, and 1 mark for my final answer. So that is your 5 marks on exponents. I hope you understand so far. Let's go to the set. So in 1.5 now and 1.6 we're solving for x, meaning we're giving you equations. So they gave me 3 to the power x equal 27. So with exponential equations, either we're going to try to make the bases the same or the exponents the same. In this case, we're trying to solve exponents, so the bases must be the same. So 27 can be expressed now as 3 to the power 3. So if you have a Casio FX82, say 27 equals shift fact, and it will give you 3 to the power 3. Now, because the bases are the same, I can drop them, and I'm left with x equal to 3. Right, 1 mark for making or writing that in exponential form, and another mark for my answer. Right, in 1.6, given to me 5 to the negative 2 equal 1 over 25x. Again, to solve, my bases must both read 5 or must be prime bases. So there, to make negative 2 positive, I wrote it as 1 and I took it to the bottom, 5 squared. 25 can be expressed as 5 to the power 2. Leave the x outside. 2 times x would give me 5 2x. Right, if I flip both sides around, that would be 5 to the power 2 over 1, which simply stays 5 to the power 2. And 5 to the power 2x, if I flip it around over 1, would simply stay 5 to the power 2x. Bases are the same, so I can drop them, and I'm left with the exponents 2 to the power x equal 2. So therefore, x equal 1. So 1 mark there for expressing this as a prime base. Another mark for writing them with the same basis, and my last mark for getting the answer. Right, so if you like what I've done so far, please remember to subscribe. Right, that way you can stay up to date with the content. I'll be uploading content the whole year, and my objective is to help as many learners as possible at no charge. Right, 1.7, can solve for x. I have base 5. 2x plus 3 equals 0,008. So I'm going to first take this and write it as a common fraction. So 8 stays on top, and if you look after the comma, I have 1, 2, 3 digits. Therefore, 3 zeros at the bottom with 1. So 8 over 1,000. So 1 mark for the common fraction. 8 goes in 1,000, 125 times, so that simplifies to 1 over 125. Well, that stays the same. Remember, to solve, I must make the bases the same. So we assume, 125 is 5 to the power 3. Right, so 1 over 5 to the power 3. If I take it up, becomes 5 negative 3. So now my bases are the same, so I can drop them and write the exponent. So now I have 2x plus 3 equal negative 3. If I take 3 over, negative 3, positive 3 become negative 3. So negative 3 gives me negative 6, and I have 2x equal negative 6. Negative 6 divided by 2 gives me negative 3, so x equal negative 3. So there, my third mark was for writing that in exponential form, and fourth mark for the final answer. So I did a whole lot of extra steps, but these are done to make sure you understand everything in between. You'll find your own way. Please don't skip steps where you see these marks. Wish you nothing but the best. Continue practicing. With practice, hard work, and discipline, you can achieve anything. Right?